So this is our unit circle that we're going to be using a lot of this semester. And it looks very complex and there's a lot of numbers on it. And it's like, oh my gosh, how am I going to remember all of this stuff? But there's a pattern to it. And if you see the pattern, you don't have to worry about memorizing things. So we've got what's called our quadrantal angles. And I'm going to be talking in radians primarily, but we'll convert to degrees in a minute. So our first quadrantal angle is here at 0 radians. And then we've already looked at the first quadrant from the previous page. We said this was pi over 6 or 30 degrees. And then we kind of moved around a little bit here. So what I want to focus on is notice in each quadrant there are 3 rays. We're going to look at the outside rays and kind of disregard the inside ray for a minute. The outside rays we're going to count by 6s. So this is 1 pi over 6, 2 pi over 6, and 2 pi over 6 reduces to pi over 3. I'm not going to worry about reducing just yet. I'm just going to go around and count by pi's over 6s. So 1 pi over 6, 2 pi over 6, 3 pi over 6. And again, the outside rays, 4 pi over 6, 5 pi over 6, 6 pi over 6. All right, so now go back through and you can reduce. Pi over 6 doesn't reduce. 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to 1 pi over 2 or pi over 2. 4 pi over 6 reduces to 2 pi over 3. A 2 will go into both 4 and 6. Let's see, 5 pi over 6 doesn't reduce. 6 pi over 6 is pi. And we can keep going around, again, by counting by 6s. So we're at 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. And again, notice I'm, again, counting the outside spokes in the quadrantal angles. At 11 pi over 6, I'm left up here at 12 pi over 6, but 12 pi over 6 reduces to 2 pi, 1 full rotation around the circle. And again, you can go back through and reduce. 7 pi over 6 doesn't reduce, but 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 is 3 pi over 2. A 3 will go into both the 9 and the 6. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 doesn't reduce, and then 12 pi over 6 we said reduces to 2 pi. Once you've taken care of the outside spokes, notice those are the kind of the reds and the purples here. Now I'm going to go back to the greens. So my greens are the pi over 4s, or 45-degree angle. So again, we start with 0, and then add 1 pi over 4, 2 pi over 4, 3 pi over 4. We're hitting the ones in the centers and the quadrantal angle. So the green is what we're counting off. So 1 pi over 4, 2 pi over 4 up here reduces to pi over 2. 3 pi over 4, 4 pi over 4 reduces to pi. The next green one in between here is 5 pi over 4. Hit the quadrantal angle of 6 pi over 4, which reduces to 3 pi over 2. 7 pi over 4, again, the one in the middle. And then 8 pi over 4, 8/4 reduces to 2 pi. So all I did was count around by 6s and then reduce when I could, and then by 4ths and reduce when I can. So again, you're counting by 4ths, but hitting the quadrantal angles. Those are the ones in yellow, and then reducing those down. So now you can go back and write in 30 degrees, 45 degrees, 60 degrees. Let me make this a little bit thicker and black. All right, so we got 60 degrees. So when I count by my 30s, so I got 30, 60, 90, and I'm hitting again the outside spokes, add a 30 to it, 120 degrees, outside spoke of 150 degrees, 180 degrees. The next outside spoke here is the red one, add 30 to 10, add 30 to 40, hit the quadrantal to 70, add another 30 to the outside spoke, not the green one, but the outside ones. So that's 300 degrees, 330 degrees, and then all the way around 360 degrees. To catch the inside spokes, we're counting by 45 degrees. So 45, add another 45 degrees, and that takes me to 90. Add another 45, and that takes me to the next green spoke of 135, or ray, if you will. The next quadrantal here, add a 45 to this, and that's going to take you to 180 degrees. Add another 45, 225. Add another 45, 270. Add another 45. So what do we get? 45 and 270. So just write it down here if you need to. So we get what? 315. And then add another 45, which should take you to the next angle, 360 degrees. So again, all I did was add 30 degrees all the way around to the outside spokes and the quadrantal angles, and then 45 degrees to those inside ones along with the quadrantal angle. So I can't go from here to here and add 45. I've got to hit the quadrantal angle as well as you go around. And that's how you fill out the chart. So on your own paper, go ahead and see if you can then recreate the chart, adding pi's over 6s, pi's over 4s, 30 degrees, and then the 45 degrees all the way around. This last part of 2.1 involves two formulas. One is the arc length. Arc length is this S. This S is the outside edge. That's what an arc length is. So what we do is we multiply the radius times the angle theta, but theta has to be in radians. That's the big key. The formula is not hard, S equals R theta. What's hard is remembering that the theta can't be in degrees because we can't have a unit label on there. It's got to be in radians. So when I do this, it says find the arc length. They want to find S. So S equals R theta. S equals R, which is 2 inches. I'm going to put the unit label there. And then theta, I don't want to put degrees in here because then the arc length is going to be in inches degrees. The arc length should just be in inches. It's a length. So that's why I have to change 30 degrees to radians. So I can do it by hand this way, or if I've memorized my chart back here, I know that 30 degrees is the same as pi over 6. All right, if I forget that though, I can calculate it out. 30 pi over 180 reduces to 1 pi over 6. And then put in pi over 6. So you have to be careful on MyMathLab. Sometimes they ask for an exact answer. So I multiply straight across 2 pi over 6. All right, and then reduce that down, pi over 3. That would be the exact answer in inches. Sometimes, though, they'll want you to round it to 3 decimal places. So that means you're going to take your calculator and type in 2 pi. So take 2 use the pi symbol. Don't put in 3.14 because that'll be rounded horribly. So 2 pi divide 6 and get 1.047. And then put the unit label on there, inches. All right, if I do the same for this next one, S equals R theta. So S is 2, R we don't know. Theta is already in radians, so I just put the 1/3 there. To solve for R, I could divide both sides by 1/3, but I've got to use parentheses, otherwise my calculator is going to lie to me. Or I could simply multiply by 3 and clear off the fraction that way. So R equals 6, and again it'd be in inches, nope, feet, my bad. All right. The other formula is the area of a sector. So that's area, and that's going to be in square something, square feet, square inches, square meters. Again, area equals 1/2 R squared theta. Theta is in radians. All right, so 60 degrees. Figure out what that is in terms of radian measurement. All right, so 60 pi over 180. And then, again, if you're going to use your calculator to help reduce, don't put the pi in. Just put in 60, divide 180, and then do math, enter, enter. All right, so pi over 3. All right, so area equals, all right, 1/2 R squared, and then pi over 3. I don't know why this is hard for students. This is just multiply straight across. So 2 squared is 4 pi. 2 times 1 times 3 is 6. All right. If they want an exact answer, reduce the fraction to 2 pi over 3, but they're asking for a decimal. So again, with the calculator, 4 pi divide by 6. So 2.09, how many places? 3 places, so 2.094. All right, and this was in feet, but remember we squared the 2, and square the feet means this is going to be feet squared as a unit label. All right, try this next one. We're looking for using the area formula. So area equals 1/2 R squared, we don't know what that is, and theta is already in radians, so I don't have to worry about that. So 2 equals, multiply straight across, 1 R squared times 1. 2 times 1 times 3. To clear fractions, multiply both sides by 6. And from our algebra days, to get rid of the square, we take the square root. Usually we put a plus or minus in here, but because it's the radius, it's going to be positive. And to round it to 3 decimal places, hit it with the square root of 12. So 3.464. All right, this is the radius, so this is just going to be feet.